I'd like to invite on the stage the Purple Foundation principal architect that you know all very well, Wouter Cloetens, for explaining the role of the silicon vendors, OEMs, and low-level developments. Please, Wouter, come on the stage. Welcome.
To have the theme song to Back in Black playing because, you know. Okay, right. So since the beginning of the year, I'm the Purple Foundation principal architect. Anyway, so since the beginning of the year, I'm the principal architect of the Purple Foundation. I now work there full-time. I've been with Purple since 2015, working for multiple different companies, system integrators, operators, and I feel like I'm where I belong now. And I'm really happy to have some of the things that I envisioned come to fruition, especially this year. So there's a lot of evolution in this year, which Peter Steinhauser has already introduced here. But let me begin just simply by making the problem statement. This is part of the webinar that I did recently as well, in which I delved in a little bit more deeply into that. So, what is the problem? So the low-level API is really about the interface towards the silicon vendors. So if you look at a PC and you take Linux, because we're all using Linux on these embedded systems, you can put in any hard disk, you can put any SATA controller, you can put any network card in there, any video card in there, any USB host interface, and it just works, right? Linux has these drivers for all of them, can dynamically detect which kind of hardware is in there over PCI, over USB, whatever, and everything just works. This works on PCs, this works on servers, and quite a lot of other devices. Why doesn't it work on gateways? Why do we need to spend so much time, and I'm really talking typically 1 to 2 years of development to do an integration on a particular hardware? That's what we're trying to fix here. That's what we're trying to close that gap. Now, so what are the problems there? There are some silicon interfaces that are not in PCs and in servers, etc. First is the access network. It's the whole point of a gateway, right? DSL, GPON, DOCSIS, 5G, etc. is just not present typically on PCs. So there is not really an API for that has been developed. There's no subsystem in there that covers this. For cellular, it's a bit better than that. What you also typically have in a gateway is an embedded switch. That can be a switch fabric with a bunch of physical Ethernet ports and MAC interfaces on it, but it could also be a switch fabric towards the GPON baseband and other complicated access network interfaces. These need to be managed as well. Because in a PC, there would just be an external Ethernet switch that you can go and configure by your own if you need something special to happen on this. No, this is integrated in the gateway itself. Then you have hardware packet accelerators because you don't want to burden the CPU, and even modern-day CPUs, especially in these embedded devices, are not going to be able to do 10 gigabit per second of traffic. It's just not feasible, and it's also not energy inefficient. So there are generally co-processors in there that handle this sort of things. So this is missing mostly from Linux. There's something of an interface towards packet accelerators development. We're not there yet. So what do we have? We have a number of silicon vendors in this specific space, in this specific niche, who have all on their own, in isolation, obviously, not collaborated with their competitors, developed this. And that's the problem that we're trying to address here. Other problem is so on a PC, you just take standard Linux, you download the Linux kernel, you build it, it works. Sometimes you might need to get a driver if there's some newer hardware than the Linux-specific Linux kernel version. This is really not so a lot less so in the embedded space, and in the gateway space, it's a bit more complicated even. There is an SDK, a software development kit, or board support package, if you will, which contains a specific kernel version that the silicon vendor has tested. That may be old. It has been traditionally sometimes really old, many years, easily 6 years old. That comes with a number of problems, as in not supporting the newest features, and also security issues at some point in time. Second is, obviously, the different silicon vendors will not coordinate with yourself. So we're trying to build here in an open ecosystem, an open software stack. But then you need to do this for this silicon vendor, that for that silicon vendor, that for that silicon vendor. It's not really quite aligned. Another big hurdle is that all of the documentation and the SDK of the silicon vendors is typically under NDA, non-disclosure agreement, which means that it's secret and you can't just collaborate with each other on it, which makes it really difficult to make an open source organization that handles this. And then the next problem is that if you want to do hardware, well, you can get reference boards from silicon vendors in small volumes, sometimes very expensive, sometimes you get them for free. And these are also under NDA. Sometimes the contracts are even such that these devices can only be in this specific address on this office location of your company. You can't even move it around. So yeah, this is inefficient for us. And it's not just for the community that is doing the development and all the different vendors. It's also inefficient for the silicon vendors themselves, really. Because they have to keep reinventing things and they have to do custom support for their stuff to every new customer that they have. To the point where you have silicon vendors who will say that we're only interested in so many big customers, and the rest of you, we don't even want to talk to you. So that's what we're trying to fix here. So this, I'm not going to read the entire slide. This is just a wall of text for you to look at recently. It really is the purpose of the low-level API purpose of the low-level API the purpose of the low-level API working group is to address these issues. So we're going to find out where are the gaps, which software interfaces are missing, and then we're going to work with the silicon vendors to come up with common interfaces. We're going to say that we're not going to make up our own. We're not going to say that, oh, well, nobody's using a standard. Let's make a new standard. Which is then not common either. No, we're specifically targeting to make sure that these low-level APIs are aligned with the Linux kernel to the extent possible. And we take a realistic approach. Sometimes it's a phased approach to get there. We want these interfaces to be open, so we're definitely not going to allow anybody to come up with a proprietary interface. So that's the biggest challenge typically. The silicon vendor says, oh, we have this new technology. We saw this with Wi-Fi 7 recently. We have this new API to address this new feature. Yeah, okay, that's not acceptable. We will come up with something common. This is what we're in the last year doing quite a lot, is finding where the gaps are, seeing, and I'll get to that later. And we want to make sure that if there are pieces of changes that we make to interfaces, that we define themselves, that we work with the open source community, upstream it back to Linux, upstream it to the host AP project that manages wireless, upstream it to Network Manager, which we're going to use for the management of cellular interfaces, etc. And then the rest is documentation, publication. Compliance testing is the next thing. We are in our certification roadmap, prpl certification. We have a target to support a low-level API certification. It's not on the list for 2024 yet. Hopefully next year we'll get around to it. But at some point in time, you will only be able to get a prpl certification logo if you are completely low-level API compliant. And that will probably be in phases in the sense that, well, you know, there's the standard of this year. These standard interfaces don't quite exist yet. We will accept these intermediate stages where you have a piece of proprietary code to abstract things, but be aware that's going to disappear next year. So it'll be an evolving standard moving forward in a particular direction. And the rest is just us. So this has been published. What we've done so far has been published in the prpl low-level API recommendation, which is up on the documentation section of the website. It's 2 or 3 years old by now. I've really hadn't had the time before to work on that a lot. There are a bunch of updates that we're doing in our own Confluent site internally and that we're actively working on. I know at some point in time, hopefully, I'll be able to publish a new version, which is a 2024 version. But I get this question a lot, and it's a fair question that, hey, the standard that's in there is 2 years old or 3 years old. Do you have anything new? Yeah, just please come and look at the work we're doing or join the group. Okay, right. So now we get to what the big step forward is, and the big step forward is this, reference hardware. Because it's all good and fine to define, to put a bunch of text on in documents to say how it needs to behave. We actually need to have the lived experience of doing the integration. And we get that with the reference platforms. So it's great that we have now MaxLinear and Qualcomm specific reference platforms, and more are coming up. We're talking to the other silicon vendors as well in the space, so that we have real hardware to work on, doing real builds and fixing issues that we come across by seeing what we need to do. Because that's the way really in which you improve the standard, is implement it and then deploy it and then get the feedback and see what we're missing. This is how we identify the gaps really. But it took us a while to get there. So the first problem is, as mentioned, yeah, some of the documentation and code is under NDA. We've come to an agreement both with MaxLinear and Qualcomm to have some sort of a communal NDA. For the documentation, everything that is proprietary that we might need to get access to, the individual companies working under Purple, not the Purple Foundation itself. The Purple Foundation itself does not sign NDAs. That's not its position. It doesn't have employees per se. It has subcontractors. I myself am an independent consultant itself. So we all sign the NDA individually, and then there is a communal aspect to it that we can share with each other. Let's see. Well, all of the bullets that I have in there are really what I've described already, as in we're going through this lived real life experience of improving these platforms. So using the light NDA, or preferably no NDA at all, but I don't think any silicon vendor is going to want to do that, is the first step. The second thing is that we've mandated that this hardware would be purchasable by everyone. And we even have on our site, we even have detailed schematics, GPIO diagrams, everything to work on these devices is there. The devices themselves you can buy. It's on our public wiki, which is on GitLab. So you don't even have to be a Purple member to get access to that. Anybody can buy it, anybody can access it, anybody can build Purple OS from scratch with all of the source code available, with a possible exception in that some of the code might also require an NDA. This is not something that we want to have. That is not the case for Qualcomm today. We're working with the other silicon vendors to make sure that they release their SDKs in open source. So we get direct support from the silicon vendors. We've set up meetings this year in our platform support group, which is under the guidance of the low-level API working group. I'm saying all of this, but it's really just myself and Mahipati. So we work directly with the silicon vendors, and we go through the issues and we clear those up. And it's been a good collaboration so far. And then we fully support and test it. And that's the important thing, because you can say that, okay, let's make an open reference platform like the Turis Omnia or the GLINet device that we've had before, a retail purchasable device with a completely open source kernel coming from the community. But it doesn't give you the experience of the hardware that's really getting deployed in silicon vendors. So we're not only doing this, which means effectively that if you take the stack and then you want to say that now we're going to make a product out of it, you have a lot of hard stuff to work through. We're doing that for you. It seems that was the last of my slides, but Is there a way for me to come back still? Yeah. I did take some other points that... so I really like that Yigal pointed out completely at the end of his presentation, he pointed out that this is not a way to... This is a challenge for the silicon vendors sometimes because they might have, and other hardware vendors, because they might have traditionally seen this as their secret sauce and possibly being able to lock in some of their customers. It's really the other way around. What we're trying to do is, and I have this experience working in an operator, in a system integrator, doing hardware and deploying it from scratch, from starting to work on reference hardware, is that we're making it as easy as possible for anyone to take a working software stack, carrier grade stack, and deploy it on the silicon vendor's hardware. A lot of the support that we're getting from the silicon vendors is going into the stack to make sure that you don't have to learn. You don't have to test this and find out where all the ugly bits are that need to be fixed. It's all been done for you. So that is the challenge here. That is the big difference we're trying to make, is reduce that 1 to 2 year integration period and reduce it to a minimum, as in ideally, in a perfect world, just the differences between the reference platforms and the hardware that you're really deploying into the field. Another aspect, but we'll get to that later, which is that something that Peter mentioned in his talk, that we're working on the bootloader as well. I'll get into that later. I have another talk later, and there is the security workgroup presentation that will get into that as well. Essentially, we're not just looking at the Linux side, we're looking at everything. We're looking at the manufacturing interfaces towards the manufacturers of the hardware. We're looking at secure execution environment. We're looking at a bootloader and the entire secure boot structure. So we're looking at those things as well, and we're trying to standardize those as well with the silicon vendors and bring those up to, as much as possible, open source. Okay.
Thank you, Wouter. We'll see you again up on stage in a couple more times, too. So thank you.